So here's what we got. This ugly problem. I've never done this problem before. How long did you guys spend on it? 20 minutes? Probably? And you would try it once and you get stuck, or you think you're done and then you think about it and you think about the other stuff you learned and you're like, wait a minute. And you go back, right? Okay, so let's see. Here's what I noticed. I've got 1, 2, 3, 4 of those, right? So if I write it out very carefully, this is what I get. Is that good? Now here's one thing I also noticed. This is 4 squared. Is that okay? Uh-oh, she's already changing her answers. So here's what I would like to do. Because let's say let's say you asked me to give you a similar problem, right? So this is similar.
It's not similar.
No, it's look, this is 4 squared and this is 4, so that'd be 4 cubed. I could combine those right now if I wanted. Yeah? Now what do you do when the bases are the same? These are both 4 and you have exponents. Don't you just, isn't it like this thing again? Isn't that what it would be? You would just add those. So what is 2x plus 3? I think it's just 2x plus 3, right? I think that's it.
You think so?
I think that's it.
And could it be 4, 3 plus 2x?
Oh yeah, it could be 4 and 3 plus 2x. That's the same thing. Okay, you're gonna this is gonna come into play later also. These problems, I think they're
which order you put them in, like that?
this or this now?
Yeah.
Usually we write it like that, so that's probably more comfortable.
Yeah, right.
But
the other one would still be right?
oh yeah, absolutely. This is right. That's right. Okay. This next thing I'm going to show you is going to tie into stuff we're going to do in a little bit. Like later.
Invisible
Nope.
one in that 4 times 4 is the one area I had mixed.
Oh, okay. But this ties into what we're going to do later. Check this out. This 4, would you agree this 4 is 2 squared? Would you agree with me?
Mm-hmm.
Yeah? Okay. Now this is the right answer. It's perfectly acceptable, but I'm going to show you something else you can do, and I'm going to try to expose you to something that you didn't know you didn't know. Because then if you realize you didn't know that you didn't know it, then you can learn it. Right. All right. What do we, now, with this right here, would this be kind of like, yeah? And you multiply those exponents, yes? So I have to multiply this exponent by this. And I know you know how to multiply those, but the tricky thing is it's not going to be, I'm going to write down the wrong answer, okay? Here's the wrong answer. Yeah, you have to multiply 2 times all of it, so you would also have to multiply by that right there. So this answer isn't better than this answer. They're the same. But I just wanted to show you how these exponent things like this work, because you're going to see stuff like that in the future in other math classes. Okay, how could I check if this is right numerically? Can we plug in a 2? Okay, that's a big ugly number. Let's plug in a 2. Let's say x equals 2, right? So this would be 4, 4, 4, and 4. Is that right? Okay, what is 4 to the 4th? 4 to the 3rd is 64, I know. So 16, 20, 256. Okay, so each of these 4 to the 4th is 256. So I'm going to go ahead and write it on another piece of paper because it's getting kind of ugly. And I want it to be beautiful like all of you. So here's what we got. We got 16, 4 to the 4th, plus 4 to the 4th, plus 4 to the 4th, plus 4 to the 4th. And what we want to see is if this is really equal to 4 times 2 times 2 plus 3. We want to see if, oh, you couldn't see what I was writing the whole time, could you? And you didn't even say anything. Wow. Okay, we want to see if these are equal, right? We're plugging in a 2 for x, and these were all 2x, right? So 2 times 2 is 4. And each of these is 256. So 256 plus, so that would be 4 times 256. Oh, man. Times 16. That's an ugly number. Isn't that an ugly number? Here's what I would like to do instead. I would like, oh, man. I did not plan on this, I swear. But this is freaking amazing. Watch. You ready? Are you sure? Are you ready? Watch. Check this out. This is 2 to the power of 4.
Okay, I mean 4 to the power of 2.
No. 4 to the power of 2. 4. Oh, yeah, it could. You're right. I'm sorry. Forgive me. I hate my life. Now, this is 2 squared. And I think 256 is the power of 2. Let's see. 2, 4, 8, 16, 32, 64, 128. What's 128 plus 100 times 2? Is it 256? A la bestia. 1, 2, 3, 4, 5, 6, 7, 8. This is 2 to the power of 8. Do you see why I'm doing this? I'm doing this because these numbers were getting so big. Because this times 4, it's like 1,000. Times 16, that's a huge, giant, ugly number. I would probably make a mistake. Yes?
Why did you put here 4 and then squared and then times 2 plus 3?
Because I want to see, this is our original problem, right?
Yes.
And I want to see if this is the right answer.
Oh, so you plugged in 2?
So I'm plugging in 2 for x. Okay. Now, so this is, would you guys agree that's 2 to the 14th? Would you agree? Because 4, that's 6, that's 14? Okay. So if this is 2 to the 14th, then I would agree, I would think they're equal. So we have to see if this is 2 to the 14th. So this right here is 4 to the 4 plus 3. Would you agree?
Yeah.
And I'm not very good at math, but I think 4 plus 3 is 7. Yeah? Question is, are these the same? Do you agree with me that 2 squared is 4?
Yeah.
So I could just put 2 squared right there instead? That's 2 to the 14th.
Are you a fluent Spanish speaker, Mr.
Everything I know from Spanish I learned from the movie.
Nacho Libre?
That's everything I know. That's how I learned Chocolamano. And I learned, get that corn out of my face. That's where I learned all that stuff. Yeah. So anyway, man, that's a good problem because there's a lot of stuff that you get mixed up on, and there's a lot of things connecting. So, man. So, Jose, I am glad you asked about that. That, sir, is why you are my favorite student.
Was it 9?